Hello there. Good evening, everyone. How many people have we got? 10. Hello, Firas. Good to see you. I meant to ask you, Firas, you should put all your questions in one email and I'll answer them all in one go. Hello, Robin. Oh my God, it's actually Robin. It's not Kevin Howitt this time. Or Kevin Howitt or Phil Lawton. Yeah, there's a mixture. I can't keep up anymore. Hello, Liam, Jacob, Sean, Reese, hello. Oh, here we go. Yeah. I'm surprised Max isn't here, to be honest. I'm sure he would have piped up by now. Just wait for a few more people to come on. A couple of extra minutes. Become an absolute pro at these now. This is the last live stream that I'm going to be doing this year. Yes, I can finally have a break from YouTube live streams. I wonder if any other subject does a live stream. Maybe it's too technical. I don't know. Maybe they do a Google Meet. I'm not sure. Where's Joe? That's a good point, actually. I bet Joe doesn't actually know this is actually happening, Jacob. That's what I imagine. Hello, Sajid. Tanver. You always start off with John first. You do know you can just ask the question. Oh, there you go. There's the question. He always starts every message with John, followed by question. Fair enough. Yeah, I'll go over compilation process. If people do have requests, then you can always stick that in the chat. But my aim is over the next hour and a half to 2 hours, I reckon, is basically to go over all the topics on the topic list, one after another. And then I will timestamp this video. So if you do, get bored at any point, or you can't be bothered anymore, or you've just had enough computer science just for 1 week, then I will timestamp it so you can come back to it. I will do file organization. Yes, I will. Are you retiring? No, I'm not retiring, but technically Kevin is retiring. Can you believe that? Can you believe that? Yeah, Kevin's going down to 3 days a week, so technically he's taking retirement. So there we are. Will Kevin make out? Yeah, I have Kevin is lined up. And he'll be on for a short little interlude a little bit later on. His 1,000 question Kahoot, is that what he's making? I will go through the life cycle and compilation process. I'll show you actually what I've got. I think we've got enough people now, so let's crack on. Let's roll through these. I'm not leaving, no. Oh, there's Max. Hello, Max. Good to see you. Good to not see you. Good to see your name. Yeah. I'm not leaving. No, there's still important work to be done. Okay, there we go. I will send this out to all of you via Google Classroom after this, and I will attach the YouTube video and the timestamp as well. Anybody that watches the AS live streams, it will follow the same format. Yes, the same format. So I'll hit these parts here. If I've not covered anything, or you want me to cover anything especially, then I will go through it. But there we are. I would like to know actually if people would like logic and Boolean algebra. I know Phil's been going through that an awful lot. But basically, I can do a few questions, I imagine, or I can do some identities and things. Some people are very good at that. Some people are maybe not so good. Everything here, these topics are going to be on the exam. I can't guarantee that everything that I'm going to go through is going to be on the exam, because basically that's telling you exactly what is going to be on the exam, isn't it? Anyway, so let's start with the compilation process. It's a bit tedious, the compilation process, isn't it? But program construction is all about... Okay, let me just answer these questions first. Kevin Ware's not real in computer science. No, all the topics are on these slides. How many marks? The marks, I think it's 74. I don't know why that's come to mind, but it is 1 hour and a half. I'll give you more time than what's needed, I believe. If you remind me at the end, I will check for you. It's because I've got loads of exam papers in my head, different marks and stuff like that. But compilation process, okay? So get yourself a cup of tea or coffee or a drink of water. Relax. Try not to drift off. I will go over software development lifecycle. No problem. I've got you, Sashwa. And first, we're going to start off with the compilation process. Now, the compilation process is one part of 3. So the compilation process covers just the compiler. And we have compilers, we have interpreters, and we have assemblers. And they are all forms of translators. Tala, that's a very specific question. Very specific question. Because it's an hour and a half, there won't be any huge questions in there. It'll be a mixture of 1s, 2s, 4s, 6s, 8 markers maybe. But there we are. So these are all forms of translators. And obviously the term translator is to convert from one form into another. And in computer science, translators are basically converting from high-level source code into machine code. Simple as that. So there's 3 different types of translators, and we focus on compilers. But you've got to know the bits of all of these 3. So compilers convert source code written in high-level languages. They convert your constructs into machine code. And the process is called compiling, isn't it? It might be 70 marks, Robin. I will check at the end for you. Now, compilers have a number of advantages. And if you're aware, you might be aware of these from AS times, but compilers produce one standalone executable file, one exe file. And the point of that is that it needs no further compilation. So once it's compiled, it never needs to be compiled again, but it is architecture specific. Okay? So once the program's compiled, it can be ran many times, and that has a benefit to being efficient. Now, as well as that, because you've compiled it into machine code, into one executable file, then you are protecting the intellectual property. And that might be important to developers, especially if you're a private company and you're developing what we call competitive software. You don't want everybody stealing your ideas unless it's open source. So produce one standalone executable file. No need to further compile. Once it's compiled, it can be run many times, and that has a time benefit, but it is architecture specific, and you can protect intellectual property because it is converted into machine code. Now, comparing interpreters to compilers, interpreters, they handle the job. Intellectual property is basically my ideas. So that's my idea of code. This is the way I've done it. This is I've programmed a procedure, a function for some kind of algorithm, and it's all my idea. Yes, this does cover all topic areas. Correct. So an interpreter handles the job of translating code very differently from a compiler. So the difference here is that each line of code is translated into machine code, and we do that line by line. Now, the point of translating line by line means that every time we run the program for an interpreter, it has to be reinterpreted. Yes, you will get access at the end. So the interpreter takes the first line of source code and it begins to translate it before moving on to the next one. And remember some of the advantages to doing that. One, we can test line by line, which is usually more beneficial. But the problem is you are releasing the intellectual property because you are allowing people to see what's going on line by line. So any machine code produced while the interpreter is running is not saved. So you must interpret the code every time the user wishes to run it. So you've got a comparison point there between compilers and interpreters. Because compilers are already turned into machine code, they can be ran. It's faster than interpreting it every single time. But the main benefit to interpreters is it can be ran on any architecture, providing that we have the interpreter installed on our machine. And that might be a bit tricky. Might be a bit tricky if you're trying to deploy your program, your system across a large organization of maybe, 1,000 computers. You've got to install the interpreter on every single one. Yes, hello Kevin. How it? So why do we use interpreters then? Well, we've mentioned these already. So we use them in order to be able to run an interpreted language. So for example, Python. If you've ever used the Python idle, the IDLE, that is an interpreter. So that can run on my Mac, it can run on my Windows machine, it can run on my Linux machine. So there is, third point, this third point here. Any machine code produced while the interpreter is running is not saved. So every time you run your program, you have to start again. That's all it means. Simple as that. Any machine code produced, so you've done, let's say, 10 lines, you produce 10 lines of machine code, if it equates that way, and it doesn't save it. So when you shut it down, it reverts back to its original source code, and you have to reinterpret it again. And we've talked about some of these as well, some of the advantages. So things like source code for interpreters has to only be written once, and then it can be run on any computer, providing you've got an interpreter installed. You can easily inspect line by line. So you can inspect the contents of things like variables while the program is running. And in addition to that, you can test code much more efficiently, as well as being able to test single lines of code. So you can often produce some testing routines. It's a lot more manageable when it comes down to debugging. It's very difficult to actually debug. Well, I don't think I've ever debugged an exe file. And that's just because it's already compiled. What you do in Visual Studio is you have the code in live view in your IDE, and you debug it there before clicking start, and then when it pops up on your screen, you have compiled your program again. So every time you test your program and run it and click that start button, you are running an executable compiled program. So you think about the number of compiles that you've done in your coursework, it's absolutely insane. Every tweak, every change has to be recompiled. I imagine WYS, what you saying, John. I imagine that's what that means. But there we are. Okay, and there we go, last one. So code can be run on many different types of computer systems, architectures, operating systems, etc. Hello. I don't know who Shadow Aussie is. Oh, we're getting some guests. These might be previous students. I don't know. They tend to drift around every year, come back. I don't know what goated means, but thank you. I think it's a compliment. Now, there's some disadvantages as well. Obviously, we talked about intellectual property, but you must have an interpreter running on the computer in order to be able to run the program. Now, as source code must be interpreted each time, interpreted programs can sometimes run slowly. Okay, not always, but because they have to be interpreted, sometimes they can run slowly, depending on your system. But you have to rely on the interpreter for machine level optimizations. Now, later on, we're going to talk in a bit more depth about optimizations. But what you're doing, what this bit means here is that the interpreter itself is actually doing your optimizations for you line by line. And again, that can take time as well. Now, developers can view the source code. So that intellectual property point that we talked about, there we go. Oh, look at this. It's getting a bit heated in the chat. Oracle. Why would I want to do Oracle? Oh my days. I remember them days. Wow, Max, I can't believe. Wow. Yeah. Hey, ball. Oh, Robin as well. All right then. Now, in your exam, what you're going to do is you're going to be expected to compare these. So think about it. There's three points here, there's source code, multiple platforms, and distribution. What you're going to do is you're going to compare a compiler to an interpreter. So things like, what about the source code for a compiler? Well, the source code is hidden from other developers with a compiler, but for an interpreter, it shows all the developers and users the intellectual property, and it's at risk. Now, multiple platforms, we know a compiler is only specific for one architecture set, so that's a limitation of a compiler, but for interpreters, providing you've got it installed, it will run on any platform. Now, distribution, we don't often think about distribution of programs because it's a lot easier now than it used to be. We used to have to transfer programs around on floppy disks and all that sort of good stuff, but now you can put an executable file on, I don't know, a hard drive, portable hard drive, some kind of memory stick. You can even put it on a CD or even send it over the internet. You can stick it on Google Drive like we've done this year. And then finally, the last part for an interpreter, you can still transfer it quite easily, but the system that you are deploying it on needs to be set up with the interpreter installed so that you can run the libraries and run all the files that you need to. So you have to do a bit of forward planning with an interpreter. So if we've talked about compilers and we've talked about interpreters, the last thing to talk about of the three translation systems is an assembler. Excellent, that's great. With that Bitcoin wallet saved on a floppy disk, that's wonderful. Now then, won't be worth much anymore. So assembly language, it's code, isn't it? Simple as. Assembly language is a lower level than your high level languages that we program in. So it's a step above machine code or pure binary, and it allows the programmer to write using mnemonics. So mnemonic is just meaning for something. So it's like down here. Let me just get my. Let's go for a pen. So we've got these commands here. LDA, yeah, load at the register. You've got add storage there, halting command, etc. All we do is the system will convert its mnemonic into machine code directly. So it's very, very fast. Every mnemonic has a specific machine code instruction set. So it's often a lot faster. And we call that translation there, we call that one-to-one mapping. So LDA will have a machine code instruction, add will, STA, HLT, etc. They'll all have their own machine code instructions. In addition to that, the process of doing that is called assembling. Okay, that's quite straightforward, isn't it? Because you've got compilers that compile, interpreters that interpret things, and then you've got assemblers that assemble. Yes, mnemonic is STA, LDA, ADD. They're mnemonics. Apparently so, Robin. Apparently so. Why don't you give it a try? Okay, now you don't need to understand these because we won't be expected to program in assembly language, but all we're doing here is basically just showing the concept of one-to-one mapping. So you don't need to remember any of these, so don't worry if you don't understand any of that. And if you've got any questions as we're going through, then do fire them in. Now I've got a summary here for you because one thing we've not talked about is virtual machines. So let's say you write some source code and you were going to employ the interpreters and the compiler systems. So let's talk about an interpreter system then. Nice and simple. No. 09 Firas is just the location of the mailbox in RAM. So it's the location, memory location, that's all. It's the letters that are the mnemonics. So the top one there, interpreters, providing you've got the interpreter installed, you go straight to machine code and you carry on. Simple. A compiler is a little bit more complicated. So the compiler will convert your code into object code. It will then bring the libraries into your object code and it will link them together. And the link is quite an important process because its job is to get the libraries and embed them into your code so you don't need them externally on whatever system you're running it on. So the library gets linked to the object code, and what that does then is that produces your exe file and you can run that on your computer. So if you're going to run that and it's running, if you wanted to, for example, run a compiled program, a Windows program on a Mac, for example, then what you would do is you would, at the linking stage, you would compile your program into intermediate code, which is, consider it like a semi-compiled file. And you would open up on your computer, open up your virtual machine. Okay, a virtual machine is a piece of software that will demonstrate another computer architecture inside your current architecture. So it's like having a Windows machine with a Mac on it, or a Mac OS with Windows OS running inside it. So you can run multiple computer architectures inside your own computer. You may or may not have had a go at that before. I used to do this to get Visual Basic on a Mac a long time ago, but then I just thought it's easy just to buy a Windows machine. But we need intermediate code, and the point of a virtual machine is that it converts semi-compiled code into a specific architecture. So it can convert Windows commands to Mac commands, for example. And there are all the translation systems that we need to know about. Compilers, interpreters, and assemblers. Job done. Now that's only half the battle there, people. We've now got to look at one specific strand, the compilation process. Students tend to get stuck on this, but this is from the specification directly. So the specification states that you need to describe the principal stages involved in the compilation process. And that is lexical analysis, symbol table construction, syntax analysis, semantic analysis, code generation optimization. There's also linking in there, but hey. Now distinguish between and give examples of translation and execution errors. So at any stage through the compilation process, it potentially could generate something called translation errors and something called execution errors. And we're going to touch on those towards the end. It's this order here. So we've got lexical analysis at the start. It produces a token stream. We check the token stream for its syntax. We then produce a syntax tree. We then involve semantic analysis at that point to check that the order of variables is correct and the right arithmetic operations being applied and all that stuff. Then we've got machine code generation, optimization, and then we link everything together and off we go. Yeah, you forgot about this. Yeah. Easily done. So let's go through these, right? I'll try not to bore you. I'll try and do my best not to bore you. But it is quite a... I've narrowed these slides down to the specifics for you anyway. So here we have our source code. And in lexical analysis, the first thing we need to do is we need to remove all the white space and unneeded punctuation. And Firas, your question, unneeded punctuation is things like... in Python, you'd use a hash symbol, which is the symbol for a code comment, or in visualbasic.net, you've got apostrophe, etc. All that stuff. Hello, Funhouse. Now, as well as that, you turn the remaining code into tokens, and that process is called tokenization. And what it looks like is you take the code and you break it down into a reserved word and an identifier. Okay? So remember, error messages are produced if you have a problem at this stage. And this is, you make, obviously, it's just a compilation error. So here you can see that we have tokenized the information here. We've got an if statement. Score is made by us. This is the computer. This is us. This is the computer, etc. There you go. Computer, reserved word. And you put that in a table. Now, the good thing for you is you won't have to produce symbol tables in this exam. There you go. You're welcome. But you just need to know about lexical analysis and the process of breaking things down to tokens. Then we look at syntax analysis. So you create your symbol table. Then after that, you check the tokens to make sure they fit the grammar of the language. And you can probably tell me what grammar checks we use for this. There's no such thing as Kevin analysis. And the point of this is the compilation process. It's how you turn high-level languages into machine code. So grammar, when we're checking the grammar of something, we use things like back as no form or reverse Polish notation in order to check that the grammar matches the language. And then we build abstract syntax trees. Now that normally happens after semantic analysis, but in the textbook, they've got it a little bit early, a little bit premature. But you'll still be awarded marks wherever you put it, as long as you mention it in the compilation process. Now, if we run back as no form, I'm saying that because we've used back as no form before, we've created it. If you use that and whatever the source code is doesn't fit the grammar of your language, then we produce an error message at that point. Okay? So remember the tip that I gave people in class. If you are looking for marks and you're asked to describe any of these stages of the compilation process, if you state that if you can't run syntax analysis or you can't run lexical analysis, then if you put an error is produced at this stage, you will get a mark. Because an error can be produced at any stage of the compilation process. That's John's top tip for the day. After you've carried out lexical and syntax analysis, then you look at semantic analysis. Okay? This will do things like checking that all the variables have been declared and used. So in Visual Basic, that'll be denoted by a green line. Normally your compiler will tell you to get rid of it. Don't know if Jana, can everyone else hear me? I'm sure people can. You would have told me that you can't hear me, I suppose. Sounds like a speaker problem, Jana. Yep. Good job this is recorded. So Jana can have a look at that later on. Well done, Jana. Proof you're a computer scientist by sorting the sound out. Well done, you. Now, as well as checking all the variables have been declared and used, then we check that real values, for example, real values are floating point values. They're not being assigned to integers, for example, or you've not got integers being assigned to strings, although that would be allowed. And you check that, operations are legal. So you can't have any, mixed mode arithmetic. So greater than or equal to, that is allowed, but equal to, less than, what on earth is that? And things like this. So in Python, you might have not equal to, but in Visual Basic.net, you're looking at this symbol here for not equal to. So that's not allowed in Visual Basic, but that is. So it checks them kinds of things in semantic analysis. So we're searching for errors, and if we don't stick to the rules of the language, then we have a syntax error. As stated before, you can say an error at any point and get a free mark. I don't actually know who that person is, but you don't have to be here. Nobody has to be here. This is just free, unpaid John time. But there we are. So what actually is a syntax error? Well, it's just not matching the rules. That's all it is. So if you're asked to explain what a syntax error is, you can say that through the compilation process, when the tokens passed into the compiler don't match any of the rules of the language, then it throws up an error. Okay? Only when all the syntax is 100% correct will it build the syntax tree. The syntax tree has to be perfect because it cannot be ambiguous. So it can't be interpreted in more than one way. Oh my goodness. Rayhan, who'd have thought it? Your name doesn't really, it's just a X Spyros, whatever, AMV. Don't even know what that is. But yeah, good to see you. Now, you might remember what a syntax tree looks like. I'm sure you do. It looks very much like what Phil was teaching you about binary trees. So you might see a syntax tree looking like this, and it might have A plus B, and obviously that would be A plus B. Okay? And all we do is when we go to machine code generation is we turn these nodes into machine code. That's all we're doing. Yeah, that's true. Yeah, Joe's going to be a lifelong supporter. You can set up a Patreon, start taking donations off Joe. He'll single-handedly fund me. Now, like I said, there's no point in generating machine code if there are any syntax errors. So in order to do code generation, the compiler will perform 3 tasks. The first thing it will do is it will convert the elements or the nodes on the syntax tree into machine code, and it will allocate registers from the nodes so that we can store the information in RAM or cache if you've got it, if you're lucky enough to have that. And then finally, one of the most important parts is then we optimize the machine code to improve efficiency. So 3 things: convert the node to the syntax tree, allocate registers, optimize the code. Joe's always late. Always late. Okay, no questions coming through so far. I mean, I'll just carry on at a steady pace until people tell me off. Now, spending a lot of time on optimization here, and rightly so because it's very important. But you are all, well, we are all terrible programmers. Now, Kevin's probably old school programmers, so he probably cared about optimization himself. But nowadays, as we're writing the higher up we go, the higher level languages we go up in, the worse we get as programmers. We're getting further and further away from writing precise code. Yeah, an abacus. Yeah. See, bring it in tomorrow, Kevin. See if we can do some computer science on it. Tanvir, I'm waiting for you to ask a question. I don't know if you're asking a question or you're just writing stuff down. I'm not sure what you're doing. I don't know. But you're asking me to wait. Please explain yourself. Now then, Tanvir, you can just put something in the chat. I'm just going to carry on. Now, yeah, most programmers write inefficiently, but the higher up you go, the worse code you're going to produce. And what your compiler does is, one of its jobs is to make your code more efficient than what you have created. And it does that in such an incredibly short amount of time. So most programmers, they don't even care that their code's inefficient because they know that their compiler will sort out the optimizations for us. Happy days. So less time is spent worrying about how efficient our code is, and more time is spent on producing code. And therefore, we can do more, we can produce faster, and allow optimization, leave it up to the computer. Let it do its thing. And as we get further and further on, who knows where we'll end up? One day we'll have artificial intelligence just writing code and we'll be out of a job. Who knows if that'll happen? Elon Musk might get someone to make that kind of system, and we've all had it then. In the future, you might even have just automated teachers, and then I'm out of a job. But who knows? Who knows? So, a couple more points then. Talking about hardware and communication. So if you think about the CPU, when you studied that stuff, we talked about jumping between commands for the fetch, decode, execute cycle. And that last point is about the fetch, decode, execute cycle. So you want to limit the number of jumps that you've got to do. The number of jumps between fetching and decoding and executing. If you can reduce that, you'll have a faster program. And you might have to think about where a more efficient system is needed. You know, working in college, we don't need a very efficient system because we have time to wait for it. But if I'm creating a cryptocurrency Python mining trading bot, for example, that needs to be incredibly fast, because it needs to make live, real-time transactions. So it's got to be fast. Otherwise, I lose all my money. So there's a couple of goals. What is the point of optimization? Well, its point is to achieve the required output of the program. That sounds obvious. Hello, Robin. As well as that, we also need to increase the speed of the program. I've never been to Phil's campsite, no. Well, thank you for your question. So increase the speed of the program and decrease the demand on resources. If we optimize, we can reduce the number of registers that we're actually going to use. But then we don't delay the overall compilation process. I don't think there's any computers there, Robin. I'm sure he was using a paper-based system as well. Yeah. Obviously, he's shown you his coursework, didn't he? The coursework project, converting his campsite into a... Yeah, go and do it. Yes, okay. Akmal, yes. The last point's on the screen there, so don't delay the overall compilation process. It's a mixture, Akmal. It's a mixture of 1 and 2. I think there's one topic from component 2 on there. But those are the 4 points for the goal of optimization. Achieve the required output by the computer and program and not change that. Increase the speed but decrease the demand on resources, and do not delay the overall compilation process. Okay? If you delay the compilation process, you're going against optimization altogether because you're actually making your code slower to compile in the first place. Not a good idea. So hopefully you've got a pen and a notepad and you're making some notes here. The last 2 things, so that's going through, that's through the whole compilation process. The last 2 things we need to focus on is some examples of execution errors and syntax errors. Well, execution errors, sorry. And inside that, we've got 2 types of error, which we're going to look at now. Okay, so in your exam, an execution error might be referred to as what we call a runtime error. I am going to put stamps on yes, yes. Akmal, clearly you weren't here at the start, Akmal, when I was giving the instructions. So they're called runtime errors sometimes, and we've got a couple of different types of runtime errors. And these are errors that occur when there's nothing wrong with the code and it just randomly crashes. Oh, okay. Saji's going to do it. All right. One less job for me. And also, we've got logical errors. Now, think about this because you have all had these kinds of errors before. So logical errors are things like when you try and divide by 0. Throws up an error. We've got file handling errors as well. So that's reading past the end of file. So I know loads of people have done this. They've tried to read past the end of the last record and they've not done -1 on their record. So that's an error. And also we've got attempting to write to a file that doesn't exist. So you've either spelt the file wrong. Yeah, logic errors, part of runtime errors. Yes, yes, yes. Technically, Firas, these are all called execution errors. But most people just refer to them as runtime errors because you're trying to run it and these things happen. So they happen while running, is what I'm trying to say. But runtime, logical, and file handling errors are all execution errors. On the right hand side in that box, there's some more examples of execution errors, and you can use any of those examples in your exam if you wish. All the topics are Akmal. Yeah. I'm just giving away my Thursday evening just for a laugh. Got nothing better to do. Max, are you alright? I think Max just outed himself. Oh dear. Okay. So what I would do is make sure that you know the difference and you can recall examples for execution errors, and now we're going to look at translation errors. Translation errors. These normally happen in the compilation process. So execution errors happen while you're running your program. Once it's been compiled, translation errors happen during the compilation process. And you've had these before as well. So syntax errors are the normal ones that we refer to. That's when mistakes are written. You write mistakes, you've done mistakes in the code and it tries to compile. Stack overflow, you know, like when you've got a data structure, the stack, and you try and put too many points into it, you put too many pieces of information into the stack, it overflows. You might have a static stack of 10 elements and you try and put 11 elements in. That's called a stack overflow. Okay. So for syntax errors, they're mistakes in the way the code is written, and translators can only execute a program if it's syntactically correct. So the syntax is perfect. And common syntax errors include mistakes, spelling mistakes, or variables, incorrect use of punctuation. But your IDE, normally, it filters most of these out. So these are not very common anymore. So syntax errors. You've got semantic errors as well. Semantic errors is when you use illegal variables. Okay? Illegal variables, or you've tried to assign something to a variable that hasn't even been declared. And this gets confusing because Python allows you to declare immediately upon use of a variable. But in Visual Basic, you've got to say, dim, so dimension my variable as this data type, and then it equals to assign it, etc. Yeah, illegal variables. These are variables that don't exist or haven't been declared yet, and you're trying to use them. Yep. And you can probably imagine where the linking errors occur. That's in the linking stage of the compilation process, and simply, this is an easy one to remember, because if you can remember that linking takes part in the compilation process, linking is when libraries haven't been linked to your project. Okay? So you try and run one of your libraries and it's not been embedded into your code, the system will go, well, I don't know what that means. And that's called a linking error. Okay, linking error. So that's execution and translation errors. That's compilation process and translation systems sorted. That's one topic down. Well, that's a few topics down, not just one. But there we are. Okay. Now. Oh, it's gone white. I can hardly see it. So, which one next? So people were asking for software development lifecycle. So let's do that one. So hopefully you know that the software, I'll go to file organization after this one, I think. I'll do that third. Now, software development lifecycle, the point of the software development lifecycle is to develop software, obviously. Yeah, Robin's waiting. Is that the only one you're waiting for, Robin? I'll do it last in that case. So developing software, that's the point of it. Okay, two main approaches. You've got waterfall and agile. There are plenty more out there. Plenty more out there. You've got extreme programming. Oh, there's loads. Yeah, ACMOL. If they were dedicated and hard-working students, it would be 40 out of 40, wouldn't it? You know. And also, you know, dedicated, hard-working teachers. So waterfall. Sequential process. That means it goes in order. Notice the trickle. So you've got a little trickle going from top to bottom there. Like a little waterfall. Problem is you can never go back. That's the point of it. It's very rigid. Everything is drafted up front. Once a phase or a stage, which is one of those boxes, is complete, you do not go back again. The customer or stakeholder is only involved usually in the analysis stage, and then we leave them alone. They don't get involved again. So this is where the stakeholder is involved at, and that's because we need to run an investigation, isn't it? That's it. So there's not really much communication. All of these ones are all done by ourselves. So it's very rigid, sequential process, designs drafted up front, very little user stakeholder interaction. And the good thing about waterfall is it's very heavy on documentation. That's why the government likes it, because everybody's accountable. So when they make COVID apps, for example, that fail dramatically, they can blame people other than themselves. But there we are. The less said about that, the better. The other approach that they could have taken is the agile approach. The agile approach happens in sprints. Sprints are like these little circle things here. It's there. It's usually worth about 6 marks, ACMOL. So agile, incremental approach to development. Developers start with a simple project design and then they build on it as they go through. And the reason they can do that is because the user or the stakeholder is involved in the process. We talk to them. Simple as that. We just chat. We have a chat with them. We say, what do you think about this? Oh, yeah, we need to go back. Yeah, we need to do this. We need to do that. Yeah, okay, whatever. Now, the problem with that is sometimes the user can be too involved and they just want changes and changes and changes, and then that pushes past your deadline. The waterfall is very good at sticking to deadlines, unless the government's involved. Okay, strong communication. The clients are involved. So as we go through these steps then, again, I've tried to keep these as short as possible because, you know, life's too short to be talking about feasibility study for so long. So basically, a feasibility study, if a project fails to meet the time and financial restrictions, you could probably consider that as a failure. Yeah, because you've gone over time and you've gone over budget. So what's the point in doing it in the first place? So we do a feasibility study to make sure that we can actually do the thing. And in order to do that, you need to consider a number of different factors. So what kinds of things do we actually look at before taking on a project? I don't think there's any Boolean, Max. Or was it on the topic list? I don't think it was. Anyway. So, feasibility study, we need to ask a number of questions. Why is it carried out? Because it can save us lots of money and pain and reputational damage in the long term. We need to ensure that whatever we're doing is actually worth our time and energy. So if you did a feasibility study on the coursework, you probably would have worked out that it wasn't feasible in the time. Well, I say that. It is feasible. Then, is it technically can you actually do it with the technology available? Can it even be done? Also, will it be cost effective? So will we make enough money, and can we pay our employees, and can we pay our bills, gas, electric, rent, council tax, whatever it will be, can we pay it? And can we deliver it in the proposed timeline? So you might, we need it in 3 weeks. Nah, that's not feasible, mate. It's just not feasible. And anybody that's seen Cyberpunk, that was a failed project. Missed the deadline. Well, they tried to force it into the deadline, and it was just fail. Yeah, it's 2 T's in Petal, but that's what Phil teaches Petal. This one's a little bit more specific. So, can it be done in the proposed timescale, and can it be done on the budget given? Okay, if it's all good and all those things pass, then we actually proceed with the project. So fine, we've decided now to take on the project. Feasibility study has been passed. We move on to the analysis, which is also known as the investigation. You're probably used to that from your coursework. So think about your investigation, your coursework. What did you actually do? You engaged in a number of different investigation methods. So it's the process of finding out exactly what the system will do, or can it, or what it actually does, should I say. So use fact-finding methods. And you all know, I guarantee you know all the fact-finding methods because you've all done coursework. Okay? We need to know all the ins and outs of the system in order to design the project. If we don't get this right, it will lead to big delays and escalating costs. I drew that myself, Max. You impressed? I put pencil to paper, my classic HB. Now, the investigation, okay, there's 4 fact-finding methods. Now, I won't spend too long on these because students are normally good. I didn't make it, Max. I found it online. I'm not taking credit for that. We've got observation, questionnaires, document collecting, and interviews. Thank you, Max. Those are the 4 fact-finding methods. So if we talk about them then, observation, watching people. Now you need to be able to understand the advantages and disadvantages of these. So observing people is going into and shadowing the employee. Now when teachers get observed, what happens to those teachers? They start being nice to you. Weird, isn't it? So when you're observing people, you'll make notes on how they do their job, how they interact with systems, etc., and all that good stuff. So observing them in the natural environment. So think about the advantages and disadvantages of this. We have picking up parts of the system that are not immediately obvious to the customer. We have confirming information gathered through different fact-finding methods. So if we've done some other investigation methods, we can confirm those results by observing them. Disadvantages? Some people feel threatened. Yes, teachers are very protective of their classrooms and their students and their environments. So if you walk in on them and you start observing them and you're a member of, I don't know, senior leadership, or the principal walks in, then people start to panic. Not me. I'm not really bothered. But people panic. They start to behave differently. And that can have an adverse effect on what you're trying to observe. And there's no guarantee that some of the more subtle parts of the system will show up during the observation period, because you might be there for an hour, half an hour. Yeah, if Kevin walks in, that's the only person where I start to panic. So when we're in 242, you'll notice people walk through all of the time. And I'm I'm one of the only people that teaches in room 242 now. I don't mind people walking through, apart from Kevin. Puts me on edge. No, I'm joking, doesn't. It's fine. Questionnaires. You've all done questionnaires. It's quite difficult to actually create a questionnaire, by the way. It might sound easy, but a good questionnaire to extract proper information is pretty difficult to actually create. So knowledge of the system needs to go in there. So knowledge of how the system, knowledge of the system to be built, and the range of people to whom the questionnaire can be sent. That's what we need to think about when we're designing this. So are we developing questionnaires for the processing team? Are we developing questionnaires for the accountancy department? Are we creating questionnaires for whoever? Back-end people, database managers, I don't know. No, Max. No. What is it with you and Cahoots, man? Honestly. So this prior knowledge is essential so that questions can be targeted. And it's also important to restrict the number of choices available for each question. So don't have open questions where they can write tons of information. So keep it specific. Okay, advantages and disadvantages of these. We can be given to a large number of people at once. It's electronic now, so you can send it out. You can get a large number of different opinions because you can send it across the whole organisation. But the problem is they're hard to create and design, and not all questionnaires actually get completed. Have you ever completed a questionnaire and just lied on it just to get through it as fast as possible? You just clicked all like sevens on all of the dots, on all the radio buttons, 77777. Do you have any more comments? Just smash the keyboard and off you go. Yep, so you can actually waste people's time doing that. And then, document collection. Oh yes, this is what I think of when I think about document collection. People sifting through lots of documents to try and get an idea about the system. So during document collection, the analyst gathers any business documents that relate to how the system is to be constructed. The point of document collection is to try and understand inputs and outputs of the system, and also the processes in between. It's one of the most powerful methods to actually creating things like data dictionaries and stuff like that. So we've got documents like invoices, financial records, any other documents that are in use day to day. Now, really, looking at this one here, one advantage of document collecting is that documents cannot lie. They can't distort. The only problem with document collection is sometimes information can be redacted. That means just, you get a black pen and you marker and you scribble it out, because some information is GDPR. Will apply to GDPR. It's personal information about people, for example, so that has to be redacted if you're an external person in the company. So we've got some advantages here. Documents are reliable and they show most of the data stored in the system. Document trails help support the analyst's picture of the business processes, so it can be used with other investigation methods. Disadvantages: documents give a limited view of the system and do not say how they were created. So we don't know how they were created in the first place, because we might need to replace that process. So we need to understand what we need to do in order to make this electronic. And documents contain sensitive information, so they may be restricted. They don't always contain sensitive information, but sometimes they do. And I mean, do I really need to go through interviews? I mean, an interview is an interview. I don't know if you have a job. I don't know if you had to go for an interview. You might actually work for someone you know, so you might have never had to do an interview in the first place. But they can be quite daunting interviews. Some people can lie to sound a little bit better than they are. Well, most people lie, to be honest, until they're interrogated. So, there he is. Big Donald. But this is where analysts normally start. This is the first investigation method they normally do. And they sit down with the stakeholder and think, why? Why do they sit down with the stakeholder? Well, they do that because the stakeholder is the person in charge of the system and they might have been there for a long period of time. So it's good to see or talk to them and target some questions. And one of the main advantages to interviewing is we can get a lot of information out of the person because we ask follow-up questions. But the problem is sometimes they are time-consuming. It takes a long time to interview people. The standard teaching interview that we did a couple of weeks ago, it was about 45 minutes per interview, and we had 5 candidates. It takes a long time. So there we are. Final part there then. Final part. Interviews. Large amounts of information can be gathered because we can ask follow-up questions. Interviews produce detailed responses about key parts of the system and the disadvantages. They're time consuming, so you can only do a limited number of them. And interviewees might get nervous, so they might not always give you a fully truthful account. So you actually need to verify their responses if it's an employee. Okay? So after you've done your feasibility study, worked out what the actual problem definition is, completed the feasibility study, then you've actually done the investigation. In your coursework, you started to design the documentation. So, as a part of your design documentation, you have a requirement specification. So you put down all the objectives that you're going to actually cover. So in this requirement specification, you've got an introduction, an overall description, and the last one's the most important one, the specific requirements. So in that last part there, in the requirements, you have interface requirements, which is what it's going to look like, how it's going to perform. Functional, again, how it's going to perform and how its processes more specifically are going to perform and what it's going to be able to produce. And then finally, performance requirements, how it acts. So how quickly, how long it takes to actually boot up, how long it takes to search the database, for example, might be in there, that sort of stuff. Okay? So once you've got your specification requirements together, then you start building. You develop the software, prototypes, it might be software development, and then you get to the next important phase. And I'm sure you're pretty comfortable with this because students are often pretty good at talking about testing. Now, nobody wants poorly tested code because poorly tested code results in buggy software, and buggy software, unstable application, bad reputation. Or a lot of fixes after you've actually developed the thing in the first place. And nobody wants dissatisfied customers because that's your future business. And apparently, one person has a bad experience, they can tell 19 other people. So word spreads fast in the digital sector. Now, what people believe and what they actually create are two different things. I've marked your coursework, and I would go as far to say is I think your coursework is worse than what you think it is. So when you get a low mark for something, you're like, how dare you? How dare you, John, give me low marks on that section? Yeah, you might just be under an A star, for example, in your coursework. Cough, cough. Who knows? So the point of this is you look at your work and you think it's better than it is because you have bias towards your work. I've not seen it before, therefore I'm completely objective. So most developers find it very difficult to find most developers find it very difficult to find bugs in their programs. So what we do in testing is we will test it ourselves, but we often hand off the testing to other people. If you move on to university or go into the digital sector, it's more often than not you will be paired programming. You'll be programming with another person who will be calling out all of your weaknesses. And you feel like, you've got to be on your A game if somebody's like calling out your code right in front of you. So, because of that, we stop your testing not because of the complexity of testing, but for the fact that subconsciously you think your code is better than it is. So how do we get around that? What testing methods do we employ? So other people may take quite a different approach to using software, and we need to find bugs at all stages of testing, and testing is done throughout the program, or it should be. You shouldn't leave your developmental testing after you've actually finished the program, because that's a bad idea, isn't it, people? It's a bad idea. People didn't listen to my advice. So normally, developers pass their code on, get other people to test it. They might have in-house development teams, and better tested software is obviously more robust. No, Max, I can't. You got to earn it. So problems found later on in the system find it harder to actually fix the code. So you're trying to find the bugs as early as possible and getting them rectified as early as possible, because it can have a knock-on effect to what you develop. Okay, a knock-on effect to what you develop. And there's a type of testing called regression testing. That means if you fix a bug later on in the project, you might have to go back and test that it's not affected anything else earlier in the project. So types of testing, I wonder if you could rattle off the types of testing. Probably not. Probably not all of them. But there's quite a few. Quite a few. We have... there's two of them. I'll let you into a little secret. I'm gonna go through and look. White box testing. Gamma is not a testing. Unit testing. Black box testing. Alpha. Beta. End user testing. And finally, acceptance. User acceptance testing. So if you're asked about any of those, you need to answer the following things. Thank you, Jana. Perfect. So you need to answer the following things. If you're talking about testing, tell me when that testing is done. So at what stage of the project it's done. Early on in the development, later on, halfway through, whatever. Tell me who it's done by. Who carries out the testing? Is it the developer themselves because they need knowledge of the code? Is it an in-house testing team? Is it the end user? Is it a stakeholder? Unit testing is an automated test, Max. And unit testing is very quick. It's automated testing, but we set the tests up at the start of the project. And we use it for that thing I was talking about before. We use it for regression testing. So white box testing is sometimes referred to as glass box testing because it's very fragile. Okay, that's how I remember it. White box or glass box testing. Now it requires knowledge of how the code was developed. So you need to basically work your way through every path in the testing to work out what to test. So that's why the developer does it. Because if they have an if statement, you can work out the paths from that if statement, if else, else if, this, else, this, well, yeah, good, right, fine. Developer does it. No, Max, no. So these sorts of tests can be carried out by the developer as they understand the code. Very simple. When is this done in the software development lifecycle? It's normally done very, very early on. The white box test, the development of the software at this stage lacks functionality. It contains lots of bugs at this point. We never give this to the developer. So unit testing, just for Max, programmers, they'll create unit tests. They have software to do this normally, but they save so much time. In your coursework, when I saw you lot testing, I saw you manually typing things into text boxes. If you were testing properly, you would have a button somewhere where you could click it and it would automatically populate your boxes with invalid data, erroneous data, valid extreme data, for example, and it would run the test automatically and return a result. Okay, that's like a unit test. So unit tests, they run the code to be tested at various sets of stages and various sets of input. So they're automated. Very useful. Very, very useful tests. Everything red is the important stuff there. So like I said before, if you've got automated tests that you've set up at the start of your project to test early development, if you change anything down the line or the customer requests something further down the line, then what you can do is you can develop that into your project and then run the unit tests again to make sure that it's not had a knock-on effect to any of the foundation of your project. Rather than going back and testing the whole project again, you just run your unit tests again. And that is called regression testing, or fast regression testing. Very useful. If you have to go back and test everything, obviously that's going to have a knock-on impact into your testing time, which could push you over the deadline for something. Thank you, the real Max Bamford. Okay, written by the developer under the guidance of the methodology being employed by the project. So remember the two methodologies that we looked at: Agile, Waterfall. You've had to change your name. Yeah. Okay. Again, no questions so far. Why are there so many? So many maxes or so many tests? Who knows what the answer to that question is? Okay, fine. So we've looked at white box testing. We've looked at unit testing. So as we progress and as we develop through the code, through the project, then we need to think about black box testing. Okay, so if you might be asked to compare actually white box versus black box testing. So in black box testing, we don't actually have to have knowledge of the code. You've all, most of you have done actually black box testing scripts. So you basically just say, these are the inputs, these are the outputs, that's what I'm expecting, now go away and run it for me. And that's where you pass the code on, and you pass the script on to someone else, and they program it. Job done. I very nearly just pressed the button to end the stream. That was lucky. My goodness, don't do that again. Whew. That's it. So all you need to know about black box testing: no knowledge of the code, we pass it on to other people, they have a test script and they run it. It's very, very rigid. You do not deviate from the test script. The test will either pass or fail. How many people have we got still? No. 13 likes, 90. I nearly got more likes than I have viewers. Well done to those 19 people that are still hanging in there for dear life. Clearly an A-level means that much to you. Excellent. Our last lessons are tomorrow as well for 2 groups. 2 more lessons left. Right. So black box testing. There are some notes on it. I've already spoken about these. Well done, Liam. Hang in there. So not done by people involved in the development, because you don't need knowledge of the code. And you have a test script. If those tests fail, the developer gets the test script back and they can basically fix it, but they need to know how to reproduce the bugs. That's why the testing script is so important. It describes everything the user needs to do in order to test the thing. Otherwise, you've got no chance. If I'm investigating, people will say to me, oh, this code doesn't work. The first thing I'll do is say, right, well, rerun your code and show me exactly what you did. I need to know the steps you took in order to produce that error so I can recreate it myself. Okay? White box, unit, black box. Done. In the bag. So white box and black box are usually compared together. Unit tests have no friends. They're on their own, being unsociable. And then you've got alpha, beta testing. These two are compared against each other as well. Alpha and beta testing. Okay? So these two are this is testing that's carried out in different phases by different people. You have probably been involved in a beta test somewhere because you're all aware of beta tests and games and operating systems that come out because everybody likes free things, don't they? They like free things. Now, if you think about alpha and beta, if you remember which one comes first and which one comes later, it will help you remember exactly what the parts of this are. So in alpha testing, again, it's normally very unstable. The code is very unstable. It lacks lots of functionality. And it might not even work at all. It might not even compile in the first instance. Okay? You never, ever, 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 ever give it to the customer. Never. Because the customer will think that is what you are producing and that's what you're going to give to them, a very buggy, lacking functionality system. And that is a bad impression to give. Do not give it to the customer. It's carried out by the developer or by their in-house testing team if you are very lucky and flush with cash, because testing is a pain and nobody likes to do it. But some of you lot might even end up as software testers. So route into software development. NHS COVID test system says that it's still in alpha testing. Oh my goodness gracious me. That is worrying. That is worrying. So yeah, there you go. Now if you're asked to compare alpha testing, beta testing obviously comes after. So you just basically reverse all of these things. Oh yeah, systems analyst. To be honest, you say that, systems analysts, they're normally senior developers turned analysts because they have a very good idea of what's needed down the development line. So you normally do see managers move from software development into systems analysts. Gets paid, it's quite well paid. Now, beta testing, everything's the opposite. So it's more complete and it's created later on in the development cycle. And if it's more complete and you've done all the testing for alpha tests and stuff like that, you would think it's more stable, wouldn't you? You would do. But it may still contain some bugs and it may lack certain bits of functionality, but it is a much more stable build. Where is James? I've not seen James either. So beta tests are stable enough to give to the customer or a limited amount of end users, like you people. Limited amount. You say that, I don't think them beta, if you download a game in beta, it's not limited, is it? Is it limited by the date you can download it to? I don't know. But Windows, for example, people download Windows operating systems all the time in beta because they want a free version. But I wait till the last day of the beta download and I download it on the last day because that's normally when they've been fixing it. So anyway. So the customer will carry out beta testing, they'll have a go at it, and they will do it in a live situation using realistic data. And then when we find faults, we return them to the development team and then we can fix them. Maybe James is just waiting for the video max. Who knows? So that's alpha and beta testing. Now again, so you've got white box and black box being compared, alpha and beta being compared, you've got user, end user, and user acceptance testing. And sometimes you'll get alpha, beta, and end user in the mix. Because an end user test ensures that the system meets all the requirements, but with a greater focus on the usability for the end user. So this is about the end user using it to see if they can use it. Is it suitable for use? Do we need to change anything at this stage? So, like things like, is the interface appropriate? Does it link up via Bluetooth or whatever? Does it display to the screen? I don't know. Usability tests seek to verify that the implementation approach works for the user base. So this is where you get feedback on things like, Cyberpunk. You might play it and say, well, this is garbage. This game is literal garbage. This multiplayer that you have on Call of Duty, it's awful. I don't play games anymore. So whatever game you like. Substitute your own example in there. Okay? Max, I'm going to kick you out if you say that. Scratch is not the best. So there we go. End user testing is all about the user experience. So if we compare that to acceptance testing, when you accept something, you are accepting the requirements. Liam, do not get involved. Do not get involved. Acceptance testing occurs right at the end. It's the final phase of testing. Oh, Reese, why? Why? I'm gonna end the stream and walk off, and you won't see me till Tuesday on your exam. Anyway. So, acceptance testing, right at the end of testing. Right at the end of all the testing phases. This is where you get the stakeholder, you sit them down, you go through the specification and say, yeah, look, the program does that, the program does that, the program does that, the program does that. If you don't agree that you've met all the specification, then you can have an argument, you can have a fight or whatever you want to do, but you are looking to get paid at the end of this. So it's important that you've met all the specification. So what a lot of you students, what a lot of you didn't do was have your objectives in front of you while you were developing your system. So you are basically going off on a tangent, programming what you think you need, but you're going off away from the objectives of your stakeholders. I saw that quite a lot. And that's called project creeping. Project creeping. There you go. Don't need to know that for the exam though. All right. Documentation. 3 types. Whoa, why is that 112? What on earth has gone on there? Call yourself a computer science teacher. So, documentation. Internal documentation, that's the code itself, done by the developer. You've got comments on there, sensible variable names, that good stuff. You've also got a good layout, indentation, etc., etc. Then you've got technical documentation. Okay, so technical documentation, again, it's written by the developer. And you're passing on the technical documentation to another developer because it's technical. Lots of jargon, lots of stuff like that. So lots of technical specifications, all your diagrams from your design document and your testing documents to prove that you have done the tests and you've fixed the problems. Or you've not fixed the problems, but here you go. Here's the list of errors. Can you please fix them? And finally, you've got your user documentation. No technical information in here at all. It's more about user guides. How to uninstall, frequently asked questions, that sort of stuff. How to use the program and resolve problems if you do come up against them in the software. Okay? And that's as far as we need to go on the software development lifecycle. So I won't spend any more time on that. I will now move on to file organization. Okay, we've done testing methods. We've done that. We've done it. So that's 2 birds, 1 stone right there. Oh, okay, Max. No problem. File organization. Oh, have you all been waiting for this? Sorry, Jana. My goodness, I'm sorry. Oh, everyone's a critic, aren't they? You know. Right. File organizations. Files and file design, master and transaction. Master and transaction files, not important. Don't have to do them. Serial sequential file access, yes, very important. Hashing algorithms, yes, very important. Multi-level indexes, very important. But multi-level indexes comes under index sequential files. File security and archiving, not important in this, right? So let's just go. Let's just carry on. What is a file? I always say this, every single class gets this. A file is a collection of related records. A file is a collection of related records. And a record is a collection of related fields. So in files we have records. In records we have fields. Yeah. There you go. So I might have a personnel record and the field in there might be their ID, their name, first name, surname, RLSB, I don't know what that is, address, and location. Okay? You can have other alternatives to those definitions, but it's easier to stick with the top two. Are we all still awake? Conscious. Some people might have fallen asleep. It's been a long day for some of you. Some of you have had to do 1 or 2 lessons. Bless you all. Yeah, okay. Yeah. So yeah, normally go with these ones up there. How many people have we got? We dropped off. Oh, still got 18. Oh, look at that. Wonderful, wonderful. Whoa, well, look at this. Oh, another maxi stone. Anyway, serial files. Serial files. Now, for the exam, again, you may be asked to explain what one of these file handling methods are. Or you may be asked to compare two. You know, what's the advantage of using a serial file over a sequential file? What's the benefit of using a index sequential over a sequential file, for example? Or it might even give you a hashing algorithm to talk about and stuff like that. Why? I don't know. I don't know who writes the questions, Robin. Not me. Serial files are the most straightforward method of storing files. For each one of these, you need to know how to add files and how to delete them from each one of these. So new records in serial files, they get appended to the back of the file. Now, because of that, all records are therefore stored in chronological order. So from the time they arrive, they are put in that order. So you might think, what information is beneficial or what information is good to be stored in a serial file? So things like, we always use the example of running races and swimming races or whatever. Things that are timed are usually very good because it's in order. It's in chronological order. That might not be beneficial for storing, I don't know, student records, for example. Now, it's important to always ensure that the files have the file is open in append mode in order to, chat logs, that's a good one. Append mode. So remember when we do things like, oh, here we go, test my knowledge, test my memory, give me a pen, there we go. Remember when we did the old file open, bracket, etc. We did the channel, didn't we? We put in there whatever the file name was, and then we did open mode, dot. Okay, and sometimes we did random. Well, most people did random, even though they didn't use random access. But you can do it in append mode, in append. And that means now, no matter what you can do there, if you open it if you open a file in append mode, you can only add to the end. That means it's going to be a serial file. Serial file. So they're the points there. Open it in append mode. Okay, and no matter what you do, no matter what you try and force to the file, it will always be added to the back of the file. Wonderful. So in serial files then, the number of records is usually small. They don't require an order normally. Can you explain the like of code you just... What does that even mean? I was just saying there, I was just explaining the file handling that people were using in their coursework. When you wrote open file, etc., if we all use things like open mode random, which opens it in random access, opens the file in random access mode, but if you used open mode.append, that would stop you from accessing records anywhere. It would only let you access the back of the file. So you can basically force people to use serial file handling in that case. Okay, and there you go. There's the example of the swimming, the lanes there. But small number of records. And the reason why it's a small number of records, because when we're deleting, it's a right pain in the neck to delete stuff from it. So we keep them relatively small, these files. No. You cannot use file handling. Actually, you probably can. People have probably done it, but I don't care. Life's too short. So, okay, serial files are the most simple file handling that we can do. So stepping it up then, we can use sequential files. Okay, please remember the word sequential means in sequence. In sequence. It's not supported, Robin, by the exam board. They think it's too pathetic, and it is. So if you think about index sequential and things like this, this is technically an index sequential file. That was good, wasn't it? So each one of these, if you think about an index, we've got these identifiers in here which basically get us access to the block of data. So in an index sequential, you would jump straight to the index A, B, C, or D, or E, or F, or... No, it's missing one. So you jump straight to that, and then you would search. So instead of me searching through every single record in the file, I could just jump to the index and search the block for what I want, and therefore saves a lot of time. So starting off with sequential files. Sequential files, excellent. I'm going to answer that question, the difference between these two. So sequential files will order records based on primary key field. Okay? They are easier to program than index sequential. So that's the first comparison. Okay? Sequential files are easier to program and they have fewer overheads, and that refers to memory. Fewer memory overheads because we're not having to store blocks, index positions, etc. So there's fewer memory overheads. I don't know how long this stream's going to go on for, Robin. I have no idea. Let's just keep it organic. I'll just keep going until I drop. It might be until 4 o'clock in the morning at this rate. Now, they are suitable and faster than index sequential, but only if we have to access sequential every time. So if you have to bring index sequential, then that can mess it up. So Firas, in answer to your question, memory overheads means in sequential files, we don't have to store indexes and block positions because we don't have blocks in sequential files. So we have to store all the block information, start and end. And we also have to store the index label. But in sequential, we don't have to do that. That's why they're easier to program because we don't have to record all that information and we don't have to store all that information. I hope that's cleared it up for you. Max, no. Do physics. We can't pause for a bit. I'm on a roll. Okay? I am an endurance athlete. This is not my first live stream. You can by all means pause. Come back later on if you want. Come back later on. Watch it later. So those 3 points there cover what a sequential file does. And in a minute, I'm going to compare it to an index sequential. But whenever you're talking about these, like I said in class, students always miss the fact that you can talk about the addition of a record and the deletion of a record in sequential and index sequential. So how do you add a record in a sequential file? Just like that. All that text there looks quite complicated, but it's actually quite simple. So in order to make a record, add a new record in a sequential file, you make a new copy of the file and you copy all the records across until you reach the place of insertion. Picture it in your mind. Close your eyes. Think of a file. You make a copy of that same file. Oh, sorry, no you don't. You make a new file, sorry. You make a new file. You go in the old one. You copy all the records up to the point where you want to insert your new record in. You insert your new record in. And then copy everything across. I'm going to draw a diagram. Robin's told me to slow down. No problem. No problem. I can slow down. This is it. Oh my goodness. This is my finest work here, people. Oh, why are you doing that? Don't do... No. That is well annoying. This stupid pen. All got that? File 1. Oh, stop doing that to me. Stop doing that to me now. Okay. It's a very good question, Sean. It's because we can't shift records up and down. We can't leave blanks in the file, and we can't shift records around. So in order to do that, we have to create a gap, a space, in order to get that in. We can't overwrite information in sequential files. So this is file 2. Okay, this is our temporary file. So let's say we wanted to add a new record in here, a new number 3. Okay, this is the old file. This is the new. I hope you can see that. Yeah, you can. Okay. So what I do is I copy across all of the records that I want until I get to the point of insertion, which is here. So I'll say, right, copy this one across. So rec 1 gets copied across in this new file. Rec 2 gets copied across in this new file. And then I'm at the point of insertion. Okay? I'm at the point of insertion. So now I'll bring in my data. Whatever data I'm trying to store in there, let's call it record 5. So what I'll do is when I've found my point of insertion, I put in there my new record, record 5. And then I'll copy across the rest of the information. Rec 3, Rec 4. So this old file doesn't have record 5 in it, but now I've got this in the right position. No problem at all. And what I'll do at the end of this is all I need to do now is delete this file because it's old. And this new file, I'll call it file 1 because that's what that one used to be called. And the computer looks at it and goes, oh, that's file 1. Yes, it is, but it's got my new record in it. Ha ha ha. Trick the system. No problem. And that's all that's explaining there through that wonderful image that I've just drawn there. A true artist with a pen and a Wacom tablet. That's the process. Okay? In your exam, if you want to draw that process out, by all means, draw it out. If you're asked about it, draw it out. But I would explain it as well. Okay? Anyone got any questions on that before I move on? Robin, you good? Too fast, too slow? Happy? Not happy? There is a delay on this of about 6 seconds, so I usually get your comments in slightly after. Anybody else? Firas? Max? Liam? George? Who else we got? Try to work out who the 18 people are. Participants. Plenty. Oh, well, yeah, college paid for it, Jacob. Yeah. Yep. No, I'm good. Reese, yep. Reese, what? Doing good so far. Okay, good. So, if you can remember the addition of a record, the deletion is very similar. Very, very similar, in fact. So, the deletion works in much the same way. And you can read that information. It might make sense to you, but I'll do it again. I'll do it in a diagram, and I'll use the same stuff. So here we go. Oh, hey, whoa. File 1. That's right, Jacob. Yep, that is correct. You just leave it out. So let's go rec 1, rec 2, rec 3, rec 4. Okay? So to delete something, all you have to do in a sequential file is you have to create your new file, which is my temporary one, my temporary file, and I'll say, right, I want to delete this one, record 3. Again, I'll copy everything across, copy rec 1 across, copy rec 2 across, and I've highlighted that's the thing I want to delete. So I just ignore it. I skip on. So I'll say, right, skip past and keep copying. I'll copy rec 4 in. And that's it. After I finish that and I get to the end of the file, I delete this one. I rename this file 1. So what you're witnessing, I'm not actually deleting anything. I'm just ignoring it. I'm just not copying it across this time. And that looks like deletion. And that's how most people have done it in their coursework. You've used a sequential process, in fact. Any questions on deletion? Before I get stuck into indexed sequential files and how you delete things from there and that sort of stuff? There you go. That's a nice endorsement. Why do you sort? What do you mean? Why do I sort what? No, carry on. Okay. What? Meeting around September? No. Oh, okay. Yeah, that's the celebration evening. Yeah, I thought I've not organised to meet. What? That's start calling me out. No. That's the celebration evening. Yeah. So every year, ex-students are invited back for award ceremonies and yeah, that's still going ahead. Yeah, that's what my email was explaining. So there we go. So let's move on then. Index sequential files. So index sequential files are different than sequential files because this time, last part says which one? Yeah, the reason why it has to be sorted, Firas, if you're deleting multiple records, is because what you'll have to do is you'll have to do multiple creations of files. Okay, multiple creations of files. So if it's sorted, so when you delete something, you sort it again, it'll go back in order so you can make multiple deletions if you need to. That's what it's talking about. So index sequential files. The first thing I would talk about is the fact that sequential files and index sequential files, well, clearly it's in the name. One has an index and one does not. Okay, one has an index and one does not. And that index allows us to store records in key order in the file. Okay, key order in the file. And records are normally organised into blocks. So picture your file now. Looks slightly different. Let me get a pen again. Looks slightly different. So if this is my file, and your file will be broken up into a series of blocks. That block will carry on, and I'll have blocks down here. They're in key order. Okay? Now, you've got to be careful because the blocks might indicate an index. So like our book index, each one of these blocks, if this was a book, then this might be A. So that's the start of that block. This might be B, which is the start of this block. So all your books that start with A might be in order in the A block, if that makes sense. So B, they might be your B books in there. Okay? And now I'm sure you'll remember this in a second, but when you have an index, it allows data to be accessed directly. So if I say, right, well, let's scrap the A stuff here for books, right? Let's get rid of that, the A stuff, and let's go with a number. So this is 0, this is 1, this is 2, 3 starts here, 4 starts in here, 5 starts in here, okay? So if we said that, if I said, okay, your file will start in block 4. Okay, so I'd say go to block 4. That means I can jump directly to this section and only focus on this bit. And think about the saving of time. That is like a semi-direct access file because I can jump directly to my index. And that is one of the main advantages over a sequential file. The fact that I can jump directly to my block and then search my block. So can anyone remember how these blocks are searched? So if I had all my records in here, I need a search algorithm to work through the block. I want to search for my thing. Anyone know what that algorithm is? It is a linear search. Very good. Very good. So obviously, the more records that you have in your block, the worse it's going to be. Yeah? The worse it's going to be, because if your block is filling up with lots of records and you get a full block, then it's going to take longer for your linear search to find what you're looking for, potentially. Potentially. Okay? Now, do you remember me talking in lesson about the load factor? Now, you don't need this for your exam, but you might need it to explain something like this. You won't actually have to reference load factor, but that is basically explaining how full a block is becoming. And if a block gets over, normally it's over halfway, then it starts to become very inefficient. So we want to keep all our blocks approximately, well, less than half full, really. And what happens if a block becomes full? If for whatever reason we get to the point where a block is full, then we have some methods like overflow. So you can go at the end of a block, go to the end of all your blocks, and then start with your overflow. So I might have a section of my program here just for the overflow. Now I'm trying to keep this as simple as possible, so I'm going to recap now. I'm going to summarize this. Sequential files don't have blocks. Index sequential files do. In index sequential files, records are stored in key order in the file. The key will take you to the start of the block, and inside them blocks you have lots of records. As a user, you get to the start of your start block, which saves time already. You're straight at the start of your block, and then you linear search through the block. The more records inside the block, the longer it's going to take for you to find it. Unless it's the first item and you find it straight away and you're very lucky. So we want to try and keep them blocks less than half full. But for whatever reason, if it becomes full, or you've already placed a record in here and you're trying to put it in that position, you will be directed to the overflow. Okay? Anybody lost? So, anybody lost on that? I'm sure you'll tell me if you don't understand something. Now, if we've got index sequential files and we've got indexes, what you can do is you can talk about multi-level indexing as well. That'll still be on a mark scheme, because when I'm talking about index sequential files, in my head I'm thinking multi-level indexing. Index sequential, multi-level indexing. And basically, all multi-level indexing is an index within an index. And I used the example in class of the car park, multi-level storage car park. Okay? You might be, when you're parking up at the shopping centre or whatever, you might say, right, well, I'm going to go on the third floor, so level 3, and I might park in zone D. Okay? Yeah, kind of, Jacob. So I might do that. That's how I think about it in a real world sense. So I'm on level 3 and I'm parking in section D. So I can go straight to level 3 and then I can go and find section D and find my car in parking space 14 or whatever. Okay, it speeds up. It saves a lot of time. So multi-level indexing, there is a main index which contains the location of the next index. So floor 3 points to sections A, B, C, and D. And then minus section D, and then it points to car park spaces 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19, and also 20, minus 14. So this process may extend to several levels, and the last index contains the physical address of the record. So if you saw a diagram of this, you would look at it like, oh, these are all my levels in my file. Level 1, 2, 3. Oh, lost the ability. Losing the ability. So level 3 might point to another record, another structure that might have, let's call them zones. Zone A, Zone B. Oh yeah, my drawing's gone. My Wacom tablet has given in. Come on, there we go. Yeah, and then this might say, oh, space, whatever, space 1. I don't even know what that is. I've lost the ability to draw. Anyway, you get the point. So how do we add a record in an index sequential file then? How do we add a record in? So in sequential, we did that super jazzy create a new file, copy it across until the point of insertion, insert, copy the rest across, carry on with your life, delete the other one, rename, etc. In index sequential, it's different. Because we have blocks, we just place it in the block. We just append it into the block. Unless we want to put it in a specific position. But normally we just append it into the block. Okay? If the block becomes full, we put it in the overflow area. Excellent, Sean. Overflow. Okay? So like in the diagram I've drawn before, nice and simple. Here's your file. There's your record. Put the blocks in. Oh, I want to put it in the block. Oh, sorry, mate, it's full. So you've got to go to an overflow. And that'll be, an overflow is a space in the file after all of the blocks are finished. Okay? Nicely done. So that's how you add a record in. It seems much more simple than a sequential file, a lot less messing about. But when you have the overflow, it can start getting a bit more complicated. So how do we delete a record from there then? Yeah, this is where it gets strange. So to delete a record from this, all we do is we mark one of these for deletion. And it's as simple as that. If you're asked in the exam, how do you delete a record from an index sequential file? You just need to say the record is normally marked as deleted, but it doesn't physically get removed. You can just overwrite it. So your system thinks that it's been deleted, but in actual fact, it's still there. Nothing happens to the space, Shan. Because we're working in blocks, the space is free. Okay, the space is free. So you just mark this for deletion. Oh my goodness. Oh my goodness. Yeah. So physically, the memory is still being taken up, but we've marked it for deletion. Okay, and that is similar to the process of deleting something in secondary storage devices, if you remember. That they're not in the exam, but you know, if you remember back to hard disk drives and defragmentation and all that good stuff and trimming SSD, that is how you delete stuff on an SSD. There's a little nugget for you. So that's it. There you go. Well, no, the space... Oh, hello. The space isn't deleted. The space isn't wasted because in the future, you can work out the load of a block. So if you've got a more advanced index sequential file, you'll have your blocks in here, and you'll say, okay, one of these is being deleted, so that's gone, but my block looks full, doesn't it? So what you do is normally you would come along and you say, oh, you're in block A. I want to insert my record. Oh, insert my record. Can I insert it here? No, it's full, mate. Okay, fine, I'll move along. Can I insert it here? No, it's full, mate. Okay, fine. Can I insert it here? Yes, you can. It's good it's good. Let's go for it. So that's how storage isn't wasted overall. But that's a more advanced index sequential file. So you can use it like that as well. But for insertion, all you need to know is that it's just appended in the block. Okay. Fine. The last thing that we need to do on these files here is random files, random access. No, that's what I'm saying, Jacob. Yeah, you can add things in its place, but you need to actually go through in a linear fashion, in a serial fashion. You need to go through and check to see if this contains a record. Does this contain a record? Does this contain a record? So if it doesn't contain a record, then we can insert our record into that space in the block. Slightly more advanced index sequential insertion that, but nonetheless, still just as good. There we are. Oh, people, we're reaching the 2-hour mark. This is a marathon. This is an absolute marathon. You're all doing well. You're all doing well. Exams on Tuesday. Hopefully you got the weekend to recap some of this stuff. So moving on to the next one then, random access. Thank you, Shan. Feeling motivated. Or am I? Who knows? 6 periods a day. Let's pause for a bit. Robin, you can pause. Yeah, you can pause. But I'm aware this is all recorded. If I stop now, you'll have a massive gap in the video. I can't do that, Robin. Can't do that. I don't even have an option to press pause. But I don't need a break. I'm going to carry on. I think, to be honest, we're nearly done with the major topics, to be honest. I think we'll all be fine with most of the others. So what I'll do is I'll after this next bit, I'll take requests. So random access then. Random access or direct access. So this is where you jump directly to the record. It is the best file handling method for speed because it's direct. Jacob, there's no such thing as a workaholic. You just work. You just get the work done that you need to get done. Oh, Max, stop with the Kahoot. Stop with the Kahoots, man. You know what? I do have the Kahoot from lesson, and if I played it now, would all improve, I'm sure, because of what you've learned today. But random access involves jumping. Okay. Now remember, in that Kahoot, when you all let me down, you all let me down in that Kahoot because you all got it wrong. Yeah. And everyone's like, oh, what's that, John? It looks like cloud computing. No. This was the diagram. And still now, right, still, I stand by, well, that was a terrible drawing. That's a cloud. I'm not an artiste, I'm a computer scientist. Data, I can see the chat. I can see stuff happening in the chat, but I'm not looking at it. I'm just not looking at it. Write whatever you want, people. You were all terrible. Look, the cloud is a hashing function. Do we have a Kahoot? I'll make a Kahoot for tomorrow's lesson. We'll see. We'll see. So there we go. Just remember, with hashing algorithms, data goes in. So that might be data related to the person. Normally it's unique data, like a primary key of some sort. That goes in, gets put in a hashing algorithm, and then it spits out an index, like, you know, whatever the index is, like 1, 2, 14, 38, etc., etc. Creative mindsets, Reese. Yeah, I've seen your cow program. Yeah, he made a program about cows. Very creative in the design. Looks very good. But does it function very good? Who knows? Who's the judge of that? Who knows? Okay, so we jump to the start. Okay, we can jump to the start of a block, or we can jump directly to the actual information. The cloud doesn't have anything to do with it. It's just we don't know what the hash is, so it just goes in a cloud, like a smoky cloud, and we can't see what the hashing algorithm is. The more unique your hashing algorithm, the better, the more unique your index is, because we don't want a collision. We don't want the data to produce the same index. That is really bad. There's my joke again. The hash brown. Way! Hash brown. So you need to produce an algorithm which, when given a key, which is your data, will produce the position in the file. Victoria, hello. Victoria is one of our AS students. This is an A2 revision, Victoria. You don't have to learn about this stuff yet, you lucky person. And don't let the other students put you off. Computer science is still good in the second year. Now, it must produce the same key every time. So the same data has to go in. It must spit out the same key. Okay? Because what you have to do is when you're trying to put stuff in the record, you put the data in, it spits out the index, you go there, insert the data. If you want to find it and search for it, you need to use the same data again in the hashing algorithm to spit out the location to find it. Hi, Kevin. I am Phil. No, Robin. You're Robin. Yes. Okay. So if you're asked about random access, you need to talk about data going into a hashing algorithm and it producing an index of some kind, wherever the start of the block is or where the data lives. Okay? So direct access, we use them interchangeably, right? But direct access, this is the one where we use the blocks. Okay, so random access will go directly to the data, but direct access really is about going to the start of a block. And we know about blocks. Slow down, okay. Do you need another diagram? You all remember the worst hashing algorithm in the world, don't you? So let's do John. Into the fluffy cloud. Yeah, the cloud. You miserable lot. Let's do the length. No, there is no better way. This is no better. The cloud is everything. I physically cannot do it without a cloud. It must have one. That's just my way of showing it. The reason why I do a cloud is because you don't know what it is. You just don't know what a hashing algorithm is. Hash brown. How do you even draw a hash brown? Could you not draw a hashtag? No. No, I won't draw a hash either. I know what that means. A block that says hash. Oh, everybody. A bubble. Right, everyone's a critic. Everybody's a critic, man. Every single person's a critic. Yeah? Well, fine. You know what? Fine. We'll have no cloud then. No cloud for anyone. Fine. Are you happy? You all happy now? I don't even know how you draw an hash brown either. And I'm not doing boxes. I'm not doing hashes. I'm not even doing bubbles. So this, yeah, this on fire thing here, John goes in, it spits out the length of John, which is 3. So in block 3, it will store a record with the data John. Okay, so in direct access, it takes me to the start of the block. Now, if I come along and I go, all right, mate, Bob. Hey, you know what I've just realised, everybody? I've realised this pen, it's sensitive. Look, if I do like real soft touch, look at that. I do really hard touch. What? That is mental. This is a good tablet. Anyway, that's going to also produce 3, which will also go to the start of the block. And then we go, have you got something stored in you? And they go, yes, John is stored here. And I go, okay, what about this one here? What about this space? Well, nothing's stored here. Fine. Let's put in Bob. Thank you. Yeah. Who decides 3? I do, Sean. I made this hashing algorithm. Yeah, that science YouTuber you showed us had the same thing, but it made it look worse. Oh, okay. Dr. Donnelly, the science guy. Because that's the programmer's job, Sean, to come up with this algorithm. We call it a hashing algorithm because it just spits out an index number, a hash of some kind. But for example, I could just make this up. I could say, well, take my date of birth. Oh, I'm showing my age now. Showing my age. Take my date of birth. Use the mid command to extract this. And then, I don't know, divide it by 10. And after we divide it by 10, truncate it, which spits out the value of 9. Yeah. You could use random, but the issue with that is random is not actually random. Okay. So if we take Kevin, for example, so if we did one for Kevin was born in 1764, and we then mid the 64 off, we divide it by 10, which gives us 6.4, we truncate that, and Kevin will be stored in block 6. Yeah? Oh, 1698. Either way. Who knows? There we are. So, yeah, we just make it up. Oh, yeah. Well, we could do mod, yeah. I've just said truncate, but you could do modulus, yeah. Or you could do a div, a straight div // That would give you the whole number, I suppose. I was born in 1965. Sorry, Kev. Apologies. Oh, look at that. I've ruined my slide now, Sean. What am I supposed to do with this? Erase. There we go. I don't know. I've not outlived dinos. But yeah, direct access, split into blocks. The hashing algorithm generates the start position of the block. And the file has a maximum capacity. So, we will fill in all the blocks, and then we use the overflow again if we need to. We use the overflow again if we need to. Okay. So yeah, we know this now. We're happy with this from index sequential. Block starts off as blank data. It will fill up a bit at a time. We don't need any of this because it's not going to be in the exam. And we don't even need to talk about block overflow because again, it's not on the topic sheet specifically. As long as you talk about overflow in general, you don't need to specialize into block overflow and progressive overflow and flagging, which is another form of overflow. So I'll spare you. You don't have to do those because they're not in the exam. Okay. Okay. Do I need to do these? I don't know. Let's go back. Let me just go home. There we are. So we've done all those. We've done serial sequential, index sequential. We've done random access. That's fine. We've got programming paradigms, logic, integrated development environments, masking, clear, and encryption. Shout out what you'd like to do. Programming paradigms is things like procedural, event-driven, markup languages, object-oriented programming. IDEs is relatively quick. No, Max, no. I'll do one at the end if you must keep me here longer than what's needed. IDE and paradigms. Paradigms, yeah. Okay. So firstly, what is a paradigm? A paradigm, as some may say. A paradigm is the structure, the style in which you write your code and the approach to the programming language. Okay? So these are the ways in which we classify our programming languages based on the features that they have in them. And do be reminded that you can use different paradigms for different languages to enforce different behaviors. Okay? The first one we're going to start off with is procedural. A procedural programming paradigm. And the first thing that should come to your mind when I say procedural should be the word procedures, right? You'd think so, wouldn't you? But how many people actually write about procedures in their exam? Not many. So programs in procedural languages, they run in sequence. Oh my goodness. Step by step. Okay? That's the words that I'm looking for. Step-by-step process in your procedural language. Okay? Start to end sequentially, step by step. And what that does is that allows the programmer to define precisely each step. It's very, very specific in procedural languages. And think about, so Python, if you've done Python in the idle, IDLE, yeah, if you've ever done it in that little script thing, things work from top to bottom. So it starts at the top, works its way down. Okay, unless you meet like an if statement or a loop of some kind, it will continue from top to bottom. But it will always reach the end. Okay? So, if you've got precise control, then you can have close control over underlying operations of the hardware. So in Visual Basic, you can program specific cores for your program. You can serial and parallelize your program to make it more efficient. Okay, and then finally, one that you normally see on a mark scheme is it enables similar operations to be carried out at varying stages of program execution. And that is in reference to your procedures. So you can basically call procedures as and when you need them during execution of your program. I don't know who Funhouse is, but you don't have to be here. It's like I'm forcing you. It's like I'm forcing you all to be here. Even if no one was here, I'll just carry on. I don't really want to do this next one, to be honest. This next paradigm, because it's pathetic. And I'm going to take it off. I'm just going to take off all the example next year. So, yeah, Scratch, yeah, great, yeah, it's visual. Visual's great. Yeah, it's wonderful. The good thing about visual languages is the fact that you learn it at a very early age normally. It's easier to understand. It's not the best language. Ignore the chat. Yeah. But there we go. It's normally I'm done and in uni and I'm here. Damn. Yeah. You're here because university, although you pay for it, you just don't get this level. You just don't get this level. We're talking about Scratch here. So Scratch is all about dragging and dropping, and you apply actions to characters, also known as sprites, etc. And it makes use of the event-driven paradigm. Most graphical, if you're doing games development, you're making use of graphical user interfaces and interactions from users. Therefore, most programming languages have event-driven paradigms built into them. You have to use them in a tandem. So there we are. You could even say the dragging and dropping of a graphic user interface that we've used this year, that is considered to be visual as well. Okay? But the main point about visual is the fact that you eliminate the need to remember syntax. Yeah? A 10-year-old cannot remember complex syntax of a programming language. They can't understand what concatenation is, assignments of operators, the declaration of a variable. They don't care. They just see a stupid cat on a screen. They want to make it spin 50 times. Then be my guest. Yeah? Then they come to me wanting to learn programming when they've learnt this silly Scratch business. Anyway. Now then, event-driven. Okay? Event-driven. So this is one that we normally use. And it relies on heavy user interaction. We use this diagram normally. Okay? This diagram is basically saying, when you press a key, the operating system detects that you've done that, which it does anyway, doesn't it? It detects that you've pressed the keyboard, or you've pressed the mouse pad, or clicked a mouse button, or even touched the screen. And then it will run an event based on what you've done. Okay, simple as that. Events are all driven by user interactions. Think about some of the events you've used in your coursework. Some people have used mouse down clicks, mouse up clicks, hover overs, just standard button clicks, timer events, etc., etc. Markup languages are not programming languages. Nobody can tell me or even try and convince me that these things are programming languages. And people that use markup languages, like web developers, I don't believe are programmers. I'm sorry. Anybody that wants to be a web developer, I just cannot agree with you. That's why we have Wix. So, markup languages, their job is to mark up plain text and oh, look at that. I've got power to do things on the chat. Be nice, people. Be nice. But their job is to add commands and offer markup languages. Offer markup to text and then display it in a browser. And the point of the hypertext transfer protocol is to display these websites on different browsers, but display them in the same way. Yeah, now, good point, well made, Funhouse. Yeah, JavaScript. JavaScript is a cop-out to try and make HTML into a proper programming language. People writing JavaScript, fine. I'll take that. That is a programming language that people program in. But when you apply it to websites, oh my goodness. No, JavaScript is actually a programming language. Yeah. And you can work it in. So you've got HTML, CSS, and JavaScript. Think of HTML like the graphical user interface, the graphics of what you're looking at. CSS is the style, and JavaScript is the functionality. It's the power. It's the engine behind it. So markup language looks like this. Very simple HTML document there. You have tags, and tags are surrounded by chevrons. You can use React as well. That's a good point. That's a good one. That's becoming more popular actually. But there we are. Anyway, back to my point. Commands are opened up. So you have chevron, H1 is a header tag, for example, closed by a chevron, and you can close these commands by using a // in there, and that shows the end of a tag. So over here, with my pen, over here we have the HTML document, close the HTML document, open the header, put a title in, close the title. This is the text you want to display. This is the body of the web page. We've got a header, open and close, a paragraph, and an image. Who'd have thought it? Who'd have thought it? So yeah. So in the example, the H1 tag will instruct the browser to display, this is my web page in a header on your document. Now, in addition to HTML, we have XML, which is another markup language. Yes, indeedy. XML. It's called Extensible Markup Language, and its job really is for storage. So structuring markup for storage, but you won't need that for your exam. You won't need it. So far we've covered, what have we covered? We've covered procedural, event-driven, visual, markup, and non-procedural. Non-procedural. So again, originally, non-procedural was created for relational databases. And the point of non-procedural languages is it's more about the outcome. Okay, more about the outcome. And we concentrate on defining the inputs and outputs to try and get as close as we can to the end. Yeah, I'll do object-oriented, no problem. So those points at the bottom are really the main points of non-procedural. So those last three, focusing on rules, queries, and facts, because non-procedural stemmed from SQL languages, structured query languages used for databases. That's why you've got queries in there. Okay, it doesn't require traditional programming logic, so we use it for things like AI, grammar. I know language applications like Google Translate, for example, is done in non-procedural languages because it has to not use conventional programming logic to try and work out what the user's thinking. Okay? So for the real Max Bamford, here we go, the real Max Bamford, object-oriented programming. I've been asked an awful lot of questions about this, about object-oriented programming and what all the different things are, procedures, classes, objects, methods, or what attributes, what? But most modern day projects are actually done with elements of object-oriented paradigms. And that's because they stem from the foundation languages. Okay? So once you understand the basics of procedural, the natural transition is to move on to an object-oriented programming because it just tends to be much better. So foundation year universities, most universities look at things like Java. Python and Java are two popular ones that they use. And the reason why is because it just models the real world. People can understand it a lot easier and get their head around it because it models the real world, and it's known as It's known as object-oriented or object-oriented programming. OOP. That's what we call it, OOP. So, I've not used Kotlin. So, don't know what you're on about. Not used it. Now, you also get things like selection, iteration, assignment, identifiers, and constants like normal. But the key differences are that you replace. So, if we compare procedural and we look at object-oriented, procedural has procedures, it has variables, and with object-oriented, you've got classes which contain attributes. And attributes are basically variables in procedural. And methods basically replace your procedures. You made your control assessment. What control assessment? Okay, now classes and procedures, they're both modular. So you can actually contain them and use multiple classes and use multiple procedures to offer modularity. If you don't know what modularity is or you can't remember it, modularity is the breaking down of a problem into subproblems, similar to decomposition. Okay, but it's all about reusable code with object-oriented programming. All about reusable code. Students tend to have a decent grasp of these things. Okay, encapsulation, polymorphism, inheritance, classes and objects, abstraction. Now, what I will do is I won't go through all of these because you'll only need a basic description of these characteristics. And once you start talking about it, it's fairly easy to actually get on top of it. So let's talk about encapsulation. Okay, I'll talk about an example later on about encapsulation, but it's all about hiding things from other users or keeping classes separate. Okay, keeping objects separate, should I say. Polymorphism is a method of overriding, so it's changing behavior. Inheritance is one that students get right all the time because it's obvious. It models real world. So inheritance works the same way that inheritance happens through your genetics. You pass things down from your parents pass things down to you. Classes and objects, they are what define object-oriented programming, and it's all about reusable code. And abstraction, I don't know why I don't say anything there, but it is. It's all about reducing complexity. Wow. Okay, it's all about reducing complexity. All right. Look at that. Look at all these powers I've got as an admin. Sorry, I just went quiet. I was just hiding it. Look at that. I can hide people. Amazing. Amazing. So, advantages of object-oriented programming. These are very, very important. Very important. So, an advantage of object-oriented programming is that you get improved productivity when developing software because it's flexible. You can have multiple classes, you can create millions of objects from a template, which is a class. The software is easier to maintain as object-oriented programming is modular and reusable. So once you make one change inside one of the object-oriented programming modules or objects, then it will change everywhere. I should. Okay. Development is cheaper. think about why development would be cheaper. Because you can use reusable code, therefore you can program quicker or more effectively, and therefore get projects done quicker, so it's cheaper in the long run. Software can be tested more easily because everything is contained and in modules or objects and classes, making your system of a higher quality. And like I said, I keep referring back to the point there, software is easier to design as it models the real world. It models the real world. Okay? So my advice to you is probably get a couple of those down, learn a couple of those. Like development is cheaper, that's fairly easy to remember. What about reusable code? If you mention reusable, again, there's marks in that for you on a mark scheme, I suppose. What about software can be tested easier because things are in classes. So just get a couple of those down. But on the flip side, what about the disadvantages of object-oriented programming? What about the disadvantages? Okay, now for some developers it's okay, but for others it might not be as logical as it seems. Okay, so sometimes it can be complex to create large applications in. Yeah, it definitely, I would agree with you, Robin, it's definitely harder to learn. My first programming language that I learned was Java, and it was in university, so I couldn't even program until I went to university, which might be quite shocking, but there we go. Software can become larger, so it can grow a lot faster, so you can have more code than procedural programs. And what does that, Shan? No. Object-oriented programming, the programs can run a lot slower because they are larger. Instagram, last time I checked, was done in Python. Don't know about Facebook. Can't remember. I'm not really sure, but Instagram definitely was. Now, object-oriented cannot be used for all types of software applications. Things like machine learning and AI, it was never intended to be used for them kinds of systems, and that's why we have to employ things like Python's very good now at doing AI and machine learning, and that's what it's used for that. Non-procedural programs as well, that sort of thing. So yeah, most people learn in Python first because it's a basic procedural programming language, and it has lots of emphasis on getting the basics right. Like, it's a pain in the neck for indentation and correct spelling, uppercase, lowercase. The IDEs aren't very good for it, so it forces you to write good code, I suppose. And object-oriented programming can be difficult to debug, especially if you've got millions of objects. It can be quite difficult in that aspect. So there you go, some disadvantages and advantages of object-oriented programming. Wonderful. Okay. So there we are. If you're asked to define what objects are, what classes are, and what methods are, you need to know the difference between these things. We'll use these words interchangeably, but you need to know what they are. So an object is a combination of data and the actions that can operate on that data. So all objects are born from classes. And I use the word born, but really I should be saying instantiated. So this class here, this is the base class. This is a subclass. But in effect, we refer to those things from there as objects. So all of those down there are all objects. They are instantiated from the base class. Every time you instantiate a new object of type car, it will automatically inherit all of the attributes and all of the methods. So remember, attributes are basically variables, and methods are basically your procedures. And that is procedural programming. So in procedural, we use the terms variables and procedures. In object-oriented programming, we use attributes and methods. And these things in red are the things I want to see in your exam if you're asked about these. Okay, so if you're asked about what a class is, then I expect to see the word template or the word blueprint. If you're asked about objects, objects contain attributes and methods of the base class. Sick thumbnail, John. Okay. Interesting. Whatever you say. Whatever you say, man. All right. So inside your class, you have two main sections. You have attributes and you have your methods. So just to be really explicit, picture your class, divide your class up, and you've got, normally you have your attributes at the top, and you have your methods lower down. Everything's on the test, Akmal. All these topics are on the test. Okay, now methods, you cannot have object-oriented programming without having methods. So think about a car. This car here, oh hello, let's say this is a Tesla, it would have the method turn left. And you'd pass it in parameters like what speed are we traveling, angle of the wheels, etc., etc. Akmal, if you look at the topic list, if you look at it, really look at it, and actually read it, it says programming paradigms. Object-oriented programming is a programming paradigm. Hope that's cleared it up for you. Okay. Well, when you talk about a method, okay, in object-oriented, right? Let's say, just for Jacob, if I had a method there called calculate VAT, and I passed in total amount, all right, this calc VAT, this would be a method, because that's like your procedure, isn't it? And this would be your attribute, because that is your variable that you've passed in. All right? Yep. I'll send this out, Shan. You'll all have a copy of this. Oh, Akmal, why are you asking? No. What? Yeah, it's actually a valid question. As soon as you're finished with that textbook, you need to return it. So you might be worth returning it after your exam. So after your exam on Tuesday, it might be worth returning it back then. Otherwise, the no staff will come and get you. They will find you and hunt you down and get that textbook back. If we don't get the textbook, you end up getting billed. And them textbooks are £38 each. Oof. You do not want that on your conscience or on your bill. Yeah, if you borrowed a computer science textbook, yep. So for these, we don't need to go through these because all we need is the basic explanations of these things. Okay, so I won't go through encapsulation, polymorphism, inheritance, classes and, well, I've done classes and objects, but abstraction. Apparently, the students want a Kahoot. That's what they want. And whatever they want shall be provided. You can give it to me as well. Yeah, I can take in your textbooks. You'll have Costco cookies. No, I've run out now, Jacob. People have taken them all, obviously. Somebody brought cake in. You can always bring snacks into our final lesson ever. So if you want to bring in snacks, then by all means, bring it in. I do not take bribes. Sorry. So there we are. So let me just check, make sure that we've covered everything that we're going to need. So we've got all that in there. Encapsulation, inheritance, polymorphism, abstraction. Yes, very good, very good. Whoa, hello. Yeah, it's now in my office, Jacob. Yeah, that cake is now in my office. Oh, look at that, people. We're so close. Oh, I didn't even see your question. But yeah, we don't comment. We are apolitical people. But what I'll do, Funhouse, is this is an important time for my students, so I'd appreciate if you didn't get involved with politics at this point. Yeah? My students have an A-level to get. That's why you've been hidden. Ciao. Okay, thanks, John. Okay, yeah, okay, that's fine. If you're happy with the topics, then you by all means you can go. Yeah, no problem with that at all. No problem with that at all. Does anyone else need anything on this topic list? Got integrated development environments, masking, clearing, encryption. Please make sure you know the logic operations for those. And there's obviously logic and Boolean algebra. Okay, IDE. It's very quick, this. Very quick. So there you go. There's an IDE. Yeah. All you have to do, no problem, Firas. Thank you. Max, I don't think there'll be anyone left to play who I mean, if people are still around, then by all means. But I'll aim to finish this at past, because then all of my live streams have pretty much been 3 hours. Yeah. But there, look, here's some Python code that I created in Visual Studio because it supports Python. Happy days, happy days. And all I did today was I looked at this and said, okay, what benefits does this provide me as a developer? The benefits are line numbering, code comments. So in Python, use hash for code comments instead of a actual apostrophe. Yeah, I'll go over some stuff in a minute. Hi. We have other things in there as well, like we have breakpoints that we can put in the margin. We have output boxes here and variable watches and things like that. So these are the benefits that we have, that we get from integrated development environments. So these integrated development environments are used to see which statements/procedures are being executed at any time using stepping through tools. So stepping through is what we're talking about there. That's the advantage we're looking at, stepping through. Breakpoints are another advantage. Something called variable watches. So you can actually add a variable watch and track what value is inside your variable throughout your program. You've got obviously error messages and automatic error checking. So your IDE will try and tell you what's wrong with your program before it tries to compile it. And that also comes into error diagnostics. So trying to track down what the error is, it might give you an error code, it might say an end of file exception, it might say a integer division exception. There's loads of them. So to see the values of variables, so we can also see the value of variables and where the program failed. So when you finish running your program, you can get a report and look at where the program failed on which line, which will direct you straight in. And we call them post-mortem routines. And you're not expected to know what post-mortem routines are, but you can always, if you wanted to reference them, you can and probably get you a mark somewhere. Okay. And you've got line numbers, code coloring as well, I forgot to mention that one, and indentation. That all improves readability. Don't forget the main reason why we use an IDE, and that is to convert our high-level language into machine code. Okay, and that is it for that section of IDEs. That's all. That section there for IDEs covers case tools and IDEs in software engineering. It's a very, very short topic. Very short topic indeed. Now I might as well just hit these for the purpose of the video. So masking, clearing, and encryption. You can use any of those logical operators in order to do that. So remember, with clearing, yeah, pretty much, Jacob, but really, normally you get asked about the benefits of using it. So if you're asked to clear a register, you will be provided with a register in the first place. So you might get given an 8-bit register like 00110111. You might be expected to clear that. So you could say, well, using the AND logical operator, and please read the question, because how many times do I see students just not include the word AND like an absolute lemon? Just read the question. It will give you instructions as what to do. Normally, the 3 markers these. Normally 3 markers. So to clear it with an AND, you just use the AND logical operator to clear this. Because remember, 00011011. An AND logic gate will provide zeros wherever you have a 0, but the only time you get a 1 is when you have 2 1 inputs. So if I put a register in there that are all zeros, then obviously that's going to result in all zeros, right? Because we're ANDing them. With an XOR, again, you'll get the register. And an XOR is basically saying, well, you need to use the same register again as the clearing data, and that will produce all the zeros. Because an XOR gate says that if you have 00, 01, 10, or 11, this will result in 0, this will result in 1, 1, and 0. Yeah, it uses opposites XOR, so if you look at this, you have the same values, 0, 0, it will result in a 0. If you have a 1 and a 1, it will result in 0 as well. So these result in 0. So that's another way to clear it. Okay. So you know when it says extract the third most significant bit or the third least significant bit, what do we do? I get confused. Okay, well, what you can do is look at that kind of data there. That's what you're talking about, isn't it? With masking. It says the third most significant bit. So what you need to do, Akmal, is understand that this bit here is the most significant bit. Why? Because that will be 128 as opposed to the least significant bit, which will be 1. Okay? So, normally they point to the one that it wants you to show in order to show you which one it asks for. Sometimes in the question it will say, give me the, what am I doing? Give me the 3rd, 4th, and 5th. So you might have to go 3rd, you might go 4th, you might go 5th. It will point out which ones it wants you to do. Okay? So just remember which side's which. So yeah. Okay. Three list conveyors, 1, 2. That's right. Yeah, something like that. And obviously encryption. Hello. Encryption is one that you have to do at A2. So you would never get this at AS, but basically all you have to do is you will get some kind of register and it will say you need to encrypt this register. So you need to use the XOR operator and you get to choose the key. So whatever key you want, I'll just do 4 zeros and 4 ones. You XOR this. So 0, 0 gets you 0. 0, 0 gets you 0. 1, 1, 1, 0, 0, 0. So that is your encrypted register. And because of your encrypted register, to turn this back, you need to reapply the key again. So you'd have to draw the key out again, and you XOR it. So that would be 0, that would be 0, that would be 1, 1, 0, 1, 1, 1. And that's the original data back. So that is the very, 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 very basic form of encryption. And that's what you use the XOR key for. Okay. So remember those. Okay, last one. Last one, we'll probably get this done in 10 minutes. Might have got a few questions. So have a go. We'll see what we can do in here anyway, but normally people will struggle on these simply because they don't know these identities or how to apply them. Okay, the point is algebra and Boolean algebra follow the same trend. So if you've done algebra at GCSE, the two things that you really need to remember is the fact about distribution of brackets and factorization into brackets. So these, if you want any marks at all, you need to learn what the result of these things are down here. Okay? If you get these wrong, you've got absolutely no chance. Even if you don't get all the marks in Boolean algebra, you need to be able to recall and to produce these. Because there's no doubt in an exam, they can just give you this and say, what's the result of that? Okay? So bear that in mind. So moving on from here, we have lots of different gates to go through. So I won't bore you with the and, or, nots, nans, nors, and XORs because people are pretty good at these things. But to recap your GCSE Boolean rules, when you see a star, obviously that's anding. So normally that's a full stop, isn't it? And then you've got an or there, which is a plus symbol. These are the things that you need to really master. Okay? Don't even move on to Boolean algebra if you can't do these things. Just get a pen. All right? Now think about it logically, okay? Algebra is just basically saying a letter is replaced for a value. And in Boolean algebra, Boolean is true or false. Yeah? So it has true or false. 0, 1. So this A can only be one of two options. It can be a 1 or it can be a 0. If A is 0 and you AND that with 0, what's that going to be? And if A is 1 and you AND it with 0, what's that going to be? You need to know what the AND gate actually states. So you've got all the options, all the possible options of two inputs could be 0, 0, 0, 1, 1, 0, 1, 1. That's going to get you 0, 0, 0, 1. So if you apply that, it doesn't matter, it's always going to be 0. And if you work through these, let's say you work through these over the weekend and you actually prove them, the best way to learn these is to prove them all. So let's take, I don't know, you take whatever this is, A and A. Well, A can be 0. So if A is 0 in this occasion, well, that's the same A, so it's got to be 0. Well, what if A is 1? Well, that A must be 1 as well. So you AND those together. 0 and 0, according to my truth table, is going to give me 0. And 1 and 1 is going to give me 1. So that'll produce 1. Yep. So that's what would happen. So that is the same as that, the same as that. So it's always going to be A. So prove them all, but I don't want to spend loads of time going through them because people are generally quite good at those. At A2, in the second year, you've got something called double negation as well. Okay, double negation is where not A, or double knotted A, is equal to A. Because if I take A, which is 0, and I knot it, it becomes 1. And if I knot it again, it comes back to 0. So basically, this is the same as that. That's an A2 rule that you need to be aware of. And you need this for De Morgan's law, which is again is an A2 thing. Okay. So let me just skip on a bit. When was this a thing? Always. Always. So if you remember De Morgan's law, don't you, Jacob? So let's take A or B. Okay. And it's knotted like that. If you ever see a bar like this and you don't know what to do and you're terrible at Boolean algebra, the first thing that will always get you a mark is to break the bar and change the sign. That will get you a mark straight away. Even if you can't do it, it'll get you a mark. So break the bar, change the sign. Break the bar, change the sign. Okay. Yeah, sometimes, Jacob, you can get double knotted bars like this. Sometimes happens. So be careful. Don't see many of them at A level though. So skip through a few of these. These are all the laws that you saw on the first sheet. Well, the thing is, Jacob, we don't really cover it because it's straightforward, because if you get double knots, it's basically invert it again. So it always just becomes, you just ignore them. You just remove the double knots off. You take them off and ignore them. Absorption law. Let's get to some examples. Example, logic gate names, fine. Okay, what about this one? Should we have a crack at this? Why not? Oh, let's see if my brain can even cope. All right, so in this occasion, what I would do here is looking at this, what is the first step that I would take? I've got an A and B, and that's ANDed with brackets A or B. So what I would probably do is I would probably take this and I would expand this and I'd expand this. Okay, and that would leave me with A and B, and then it gets ANDed. ANDed, is that even a word? ANDed with A. So I'll get ABBA. On this side, so then you put the term down here, and then you A and B ANDed with B. So A and B ANDed with B. All right. So that, what does that actually get you? That gets you 1 mark because you've expanded the brackets properly. And that is a GCSE task, expansion of brackets. Okay. There we are. Then all we've got to do is use our identities now. So we used identities before, so thinking about what we can do here. There is a rule where we can use B and B. So again, if B was 0, then it's going to give us 0 there. And if B was 1, 1 and 1. If we AND them together, it's always going to be 0. It's always going to be 1. So it's always going to be whatever the same as the input is. So that is just going to be B. So that's A and B. Now make sure you show each step. So some people lose marks because they don't show each step. And I understand that you do electronics and you do Carnot maps, which are easier. We're not allowed to use them on the exam board. Sorry, it's not my fault. I didn't make the exam board, didn't make the specification. And also, you might be able to see the quick solution, but you need to be able to demonstrate every step. This one here, we might use the law of commutation, it's called. So the commutative law, where I can swap these terms round because they have the same terms. They have the same terms here of AND, so I can swap them however I like. Then again, you've got the same issue here that you had before, which is just basically A and B or A and B. And look at this. That is basically the same as those two. A and A. If you've got a cat and a cat, then you've got a cat, haven't you? If you've got a cat and a dog, or you've got a cat and a dog, you've still got a cat and a dog. So there we are. And that's how we do that one. Okay. Check our answers. Yeah, we did that. Okay. They've not shown an extra step there. Terrible exam board people. Terrible exam board people. I'll do another one, then I'll take some questions, or if people have questions or whatever. So, in this example here, we have X or Y and X or not Y. Might look simple, but they've got a not Y in there. So what do we do here? It's only worth 3 marks again, but what do we do? So again, expansion of the brackets. Expansion of the brackets. So what we're going to get here is we're going to get this multiplied by this multiplied by that multiplied by that multiplied by that. Yeah, good. Expand the brackets. So we've got X here, and then we AND that with X. So X and X. And then we've got X and not Y. So in between those, we've got an OR in there. Just be careful. It's a little bit trickier because they're both in brackets. So when they're both in brackets, you have to expand this term with those, both terms, and this one with both terms as well. Okay. So we've got X and not Y. Then we OR it again because we've got another OR in the middle. And we've got, I think it's, yeah, X and Y. And then we've got Y and not Y, I believe, which is that one, Y and not Y. So now we've got that stage there. Now we've got to that stage, then we can start using our identities again, can't we? So we can use like the X and X is just going to be X. And again, I'll write this all out for you. Gets a bit annoying, doesn't it? I should have really put the dot in there. Why not why? If you wanted to, you didn't have to actually put all of the. You could have done the Y and not Y and the X and X in both there, if you really wanted to. But hey, why not? So we've got another one there. Sorry, I'm just removing people from there. So Y is going to be 0 and 1. Oh, it's always going to be 0. So we've got X and one thing that I always do see, by the way, one thing that I do see is people forget the not bars by accident. Okay, people forget the not bars by accident. Now, what I'm going to do now, Jacob, this is probably why you're going to get lost. But what I'm seeing in here is the fact that I'm looking for common elements. This is quite a difficult jump. This. So, see if you can spot what I'm going to do. I'm going to say X is ANDed with 1, or I think I can do not Y or Y. Can you see what I did there? You see what I did? From OR to AND. It's a very good point, Sean. Very good point indeed. Yeah, kinda. Okay. Yeah, you absorb the X's. So what I'll do is I'll try and draw this out without affecting what I've done. So Sean, you said, how did I get this? Okay. Now just bear in mind that you see, like I've got an AND there. Yeah, I've got an AND there, an AND there, and there's nothing there, is there? So what I'm doing is I've got an X and Y. So this is a common term, this is a common term, and this is a common term. They're all the same. Okay, my Y and not Y is not the same. I've got 2 terms here, and 1 term here. So what I'll do is I'll draw this in for you. I'm allowed to do this. Oh, I'm allowed to do this. There you go. They've all got two terms now, haven't they? And why can I do x and 1? Because x and 1, if x is 0 and x is 1, that is going to be 0. That is going to be 1, which is basically that term there. It's that term there. So I'm allowed to bring in, it's quite confusing because simplification is trying to take things away, but I'm actually bringing things back in here to make my factorization easier. Okay. So just ignore comments, okay? If you're going to put silly comments here, then please just leave, because it's not conducive, is it, to people's A-levels. Now, once I've done that, Shan, I'm trying to factorize these x's. So I'm going to say, right, well, x, and x, take that out. And then if I take the 1, the not y, and the y, and I put them inside here, then if I tried to multiply this out, it would be x and 1, or x and not y, which is this one, x and y. There you go, put it there, job done. Okay, now this, because I did this 1 thing here, whatever is odd with 1 will always result in 1. Doesn't matter, because the OR rule states that if you have anything odd with a 1, it will always be 1. So this is going to be x and 1. And if you multiply this out, then it's just going to be whatever x is. Okay, there we go. I'm not angry, I'm a computer scientist. All right? Practice some of those, and by all means, send them in to me, send them in to Phil or whatever, and we'll, mark them for you, by all means, before Tuesday. But I'm going to stop there. I'm 3 hours in. And I just want to know, just let me know if you're still on the chat, if whatever students are still on. Stick it in the chat for me. Excellent. I just wanted to know which students are still hanging around that have done the full extravaganza. Okay, no problem. All right. As always, I mean, that's the last revision now. It's kind of, well, we've got tomorrow. We've got a bit of coursework stuff tomorrow and deadline and things like that. But it feels like we're coming to the end now of the course, and it's been a long 2 years, and you've been affected more than most. So, I'm rooting for you. Want you all to do very well. And work hard of the last push over these last couple of days, and I'm sure you'll all be absolutely fine, and you'll all absolutely smash it. And I wish you the best of luck in your exam, and I'll be there. I don't know if I'm moderating, but I'll definitely be there to wish you luck on the way in. So yeah, get a good night's rest, and I'll see 2 groups tomorrow. But thanks very much for coming. I really do appreciate it, and I'll see you soon.